shared my entire screen then.
And then you have to click on stop recording once the session ends.
I have to, okay, at the end of the session, right?
Yeah, at the end of the session, before you go out, just stop the recording and then go.
Okay.
Okay.
Fine.
Yeah. Anything else or?
No.
Yeah, fine. Okay, bye. All right.
Hello, everyone. Am I audible to you?
Yes, sir.
Yes, sir.
Okay, so I am Pranjal. I'll be your TA for May term in Maths 2, okay? And on this course, you can tag me. The tags have been given under the Maths 2 resources post, okay? So in today's session, I will be taking activity questions of week 1. So we will wait for 5 more minutes for others to join, and then we will start. Uh, yeah, one more thing. Is my audio quality fine?
Yeah, it is okay.
Okay.
Hello, sir.
Yes.
Sir, where I can access these recordings? This lectures recording.
You can access them on YouTube. I will provide you the link after the meet.
Okay, okay.
Okay, so let's start. Okay, so once again, I will be only taking activity questions in this session for practice and graded assignment. Graded assignment will be discussed after your deadline has passed, and a practice assignment will be discussed on most probably Tuesday. Okay, so let's start with is my screen visible? Can you see this one notebook?
Yes.
Where are the activity questions, sir?
So, sorry,
Where are the activity questions?
in your portal where you access the lectures, most of the activity questions are given just below the lecture. Like if you access a first video of week 1, then just below that activity questions are given.
Okay, I got it. Thank you, sir.
Okay, so can you see this one notebook?
Yes.
Okay, fine.
Yeah, it's good.
Okay, so let's go ahead with activity 1.1. Just tell me whatever doubts you have. First, I will write them. Okay, so first question, tell me uh, whatever questions you have your doubts in.
Sir, question number 8 in exercise 1.1.
Okay, question number 8. Fine. Before 8, any other question?
So can we go through quickly all the questions?
Okay, see, you are advised to go through the questions yourself and then ask. It is not good to go through every question. But if you have any doubt in any particular question which you find difficult, then you can ask. But anyways, if I observe that some question is worth discussing, then I will surely discuss that in this meet. Okay. So, okay, let's go through first question. Okay, I will eventually reach to 8th question. Okay, activity 1.1, question 1. Okay, so question 1. Choose the set of correct options using the figure. Okay, it has shown the Cartesian plane. It has given us two vectors A. Okay, so you have been given a vector. So I'm writing this vector as a column vector instead of row vector. Okay. If you have any doubt in between, you can just ping me. Okay, just tell me. Stop me in between and tell me. Okay, if you are not able to understand any particular step. Then the other vector which has been given is B vector. So it says 2A is a vector. So this is a very trivial question. So 2A vector would be this. Okay, this vector scaled by 2. So as you know, on multiplying a vector with a constant scalar, every coordinate gets multiplied with that scalar. Okay, so this would be 2, 4. Okay, so first option is correct. Okay, then B option. Okay, so 1, 8, 9, and 10. Okay, so B option is 3B vector. So again, using the same logic which we use in above option, it would be 6, 9. You can directly write it, right? 6, 9. So 3 times 2 will be 6 and 3 times 3 will be 9. So second option is correct. Then A plus B option, sorry, C option, it says that A plus B is the vector 3, 5. So let's check that. You know that to add two vectors, so A vector is 1, 2 and B is 2, 3. So to add two vectors, you add the coordinates, okay, individual coordinates. So this would be 1 plus 2 and 2 plus 3. So this will indeed give you 3, 5. Okay. So this option is also correct. Then you have A minus B. A minus B is vector -1, -1. So let's check that. So 1, 2, minus 2, 3. Okay. So this will give you 1 minus 2, 2 minus 3. So this will be -1, -1. So fourth option is also correct. So now, okay. Any other question between question 1 and 8? Anyone? So second question is easy. Again, it is quite simple. You just have to add two vectors and check whether the LHS equals to the RHS. Okay, so next is third question. So, okay, I'm briefly going through the questions. Okay, then third question says that, okay, third question is easy. Okay, so basically you have been given a table and you can see that in third question, the column vectors represents the marks of all the students in quiz 1. So under the quiz 1 header, you have all the marks of all the students. Okay. Then under quiz 2 header, you have the marks of all the students which they scored in quiz 2. Okay. So similar, again, similarly for the end sem. Then the row vectors represents the mark profile of a student across all the different types of exams, that is quiz 1, quiz 2 and end sem. Okay, so third question is easy. Okay, then you can see. Yeah,
Sorry, sir, I joined just right now. So did I miss a lot?
no, we have just started yet. Okay, we have just started, so we have completed question 1.
Okay.
Okay,
Okay.
we are on activity 1.1. So if you have any doubt, you can just tell me. I will list it here.
Okay. Okay. So you are taking doubts for week 1.
Yeah, activity only.
Okay. Okay.
Okay, so, yeah. So we were on the question number 3. Okay, so yeah, it is easy. Then fourth question is in order to improve her marks, Farzana took project work and succeeded in increasing her marks. Her marks became doubled for each exam. Okay, so anyone have any doubt in fourth question? Anyone? If you're hesitant to speak your doubts, you can also write them in the message section. Okay. Okay. So fifth question. Okay. In fifth question, it has been written that after improving her marks, people were given bonus marks. Okay. So you have to continue from fourth question onwards. Otherwise, if you directly add the bonus marks, you will get the wrong answer, right? You must have noticed this in question number 5. So it has been written following Farzana's improved marks. So first you have to do what is said in question 4, and then you have to add the bonus marks. Okay. So that was the trick in fifth question. Then sixth is again very easy. Seventh, yeah, seventh is also easy. Okay, so eighth question. Uh, whose doubt was it? Question number 8.
Sir, it was mine.
Okay, so tell me how you approached this question. I will eventually tell the solution, but just tell me how you approached.
Sir,
Yes.
actually for me that second option is I'm not able to understand how this V2 is uh, scalar multiple of A. Other thing like this V5 and V3, V4 is clear.
Okay. So see, V2, if you can see that V2 lies along the same direction as A. So V2 is, you can see that V2 is a scalar multiple of A. See, V2, okay. Okay, so A has been given as -1, 2. Okay. So first of all, see, V2 has, tell me whether V2 has the same direction as that of A.
Yes, sir, it is same.
It has same direction, right? The only difference you can see between V2 and A is the length of the vector, if you can see that. V2 is little longer than A vector. Yes or no?
Yes, sir.
So if I did something like this, okay. Okay, so suppose V2 was 5 times A. Will I get a vector along A but a little bit longer than A? See, if
Yes,
this would be
understood.
5
Understood, sir.
times,
The length will increase.
sorry?
Yes, sir. Length will increase.
Yeah, see, length will increase. Okay, so V2 represents a scalar multiple of A. Then any other option you have your doubt in?
No, sir. I think, sir, that V4 in this is because of that parallelogram law only.
V4, okay, V4 represents a scalar multiple of A plus B. So see, V4, you can see that V4, V4 lies along the x-axis. Okay, so V4 must have this sort of column vector, like it lies along the x-axis, so it should be somewhat like this, right? It should be this. So first of all, let's add A plus B. So A is given as -1, 2 plus 2 minus 2. Uh, is my handwriting fine?
Yes,
Are
sir.
you
Yes,
able to
sir.
understand it?
It is clear.
Yes, sir. Yes.
Okay, so this, see, once again, I need not repeat this basic thing. You add coordinate wise, so this would become 1. And you can see 2 minus 2 would be 0. So you can see that this vector, A plus B vector, also lies along the x-axis. Okay, and V4 also lies along the x-axis. So suppose this was A plus B. So you can again see that V4 could be represented as a scalar multiple of A plus B vector. Is this clear?
Yes, sir. Understood, sir.
Okay. Then ninth question.
Sir, actually, I have one more off-topic doubt. It is like, should I write the solution of this activity questions in my notebook, or it is like unnecessary?
See, it is eh, it is dependent on you. If you want to write, you can write. Uh, but most of the activity questions that is of level 1. See, if in activity questions there are two levels, level 1 and level 2. So most of the level 1 questions are visual and are quite easy. So you can skip writing those in your notebook. And for level 2, they are little bit tougher. So you can make notes of those questions. But it
Or
is
I
totally
can,
up to you.
or I can just simply write the question in which I'm getting doubts.
Yeah, sure, you can do that.
Okay, sir. This much only. Thank you.
Okay, so let's move on to ninth question. So it says you have been given two vectors A and B, 1, 1, 1, and B vector is 2, -1, 4. Okay, so it says CA plus 3B is equal to 4JK. Okay, so summation of CA and 3B is equal to this column vector where C, J, K are real numbers. Okay, so it says find the value of C. So again, just substitute these vectors in LHS. So this would be 1, 1, 1, 3 times 1, 1, 1 plus 3 times B vector. Okay, let me. Okay, fine. So yeah, okay. So substitute B vector 2 -1 4 is equals to 4JK. Solve the LHS. Okay, so this would become scaling this vector CCC plus 6 minus 3 and 12 is equals to 4JK. Then again add coordinate wise to add two vectors. So C plus 6, then C minus 3 and C plus 12 is equals to 4JK. So now you can equate the coordinates. So C plus 6 is equals to 4. So C is equals to -2. Okay. So whose doubt was this? Question 9.
Yeah, mine, sir.
Is it clear?
Yes, it is.
Okay. Okay. So question 10 is a continuation of question 9. Okay.
Okay.
Okay. So I'll do it anyway. Okay. So question 10. So it is find value of J plus K. So, okay. So let's continue from here. So we have found the value of C, which is -2. Now we have to equate these two coordinates. So C minus 3 is equals to J, okay? And this coordinate C plus 12 is equals to K. Now substitute the value of C here and here. You will find J and K. So J would be -2 minus 3 is equals to J. So J would be -5 and this would be -2 plus 12 is equals to K. K is equals to 10. So now find the value of J and K. J plus K would be -5 plus 10. This would be 5. Okay. So we have completed activity 1.1. Anyone have any other doubt in activity 1.1?
So I just want to know what is the meaning of number of components in column vector in question number 3. Number of
In question number 3,
number of components, that option 3.
question number 3, option 3.
Ah,
Okay, so see number of components in column vector representing quiz 2. See, basically the number of coordinates in a column vector. So if you have been given this vector A, B, C, D, so this has 4 coordinates.
okay.
So basically 4 components. So it says number of components in column vector representing quiz 2.
So there are only 3.
Yeah, there are 3, right?
Yeah.
So in quiz 2, number of column vectors representing quiz 2. Okay, so see, you can see 50, 51, sorry, 41.
41, 21.
So just count the coordinates. You have 3.
3.
So 3 components instead of 9. So that option is wrong.
Oh, yeah. Okay, sir.
So anyone have any other doubt in activity 1.1 besides these questions? Okay, so we have, okay, question 4. Question 4. Okay, so question 4. Malik, okay, 23 F3 004076. Okay, so question 4. Are you there? 23 F3 004076. Malik, Malik, are you there? Malik, are you there? You asked question 4 in the chat box. Okay, so let's do it anyways. Okay, so question 4 is the continuation of. Okay, so no, not question 4. Question 5 is the continuation of question 4. So question 4 is easy again. Okay, in order to improve her marks, Farzana undertook a project work and succeeded in increasing her marks. Her marks became doubled for each exam. Choose the correct options. Okay, so first of all, Farzana's marks are represented by the row vector. Row vector, this. So let's call this as F. So her marks are represented by this row vector 38, 21, 35. Okay. It says that her marks became doubled for each exam. So suppose let's call this as F new. So it says that it became doubled. So basically this vector was scaled by 2. So F new is 76, 42, and 70. Okay, so this is the new marks vector for Farzana. Okay, so first option says to obtain marks obtained by Farzana after the completion of project, scalar multiplication has to be done by 2. So first option is correct. Okay, we did scale the initial marks vector with 2 to get the new vector. So first option is correct. Then second option is obviously wrong because it says it has to be scaled by 1. But we saw that according to the statement, it has to be scaled by 2. Then after the completion of project, the row vector representing new marks is 76, 42, 70. So third option is correct and rest of the options are wrong. Okay, so
So one more question. So the next one, they're
okay,
saying they're saying that it is so following the improved marks,
yeah.
they are given a bonus only in quiz 2. And what is the meaning of which is given by column vector 10, 12, 15?
Okay, so see, first of all, this F new would replace the initial marks for Farzana. Okay, so I'm directly drawing the table. So it says that bonus marks were added for quiz 2 for all students after Farzana had already improved her marks. Okay,
Yes.
so so I'll write K for Karthika, R for Romi, and F for Farzana. Okay. So this is quiz 1, this is quiz 2, and this is end sem or end term. Sorry. So this is 51. Okay. This is 33. This is 50, 41, 61, 45. And you have to replace the original marks with the new marks.
Yeah.
So yeah.
76.
So you have to write 76, 42, and 70. Now it states that, yeah, bonus marks were given in quiz 2 for all to all students. Okay. So basically, this column vector
is added.
will
Right?
will get updated. Okay. So let's say quiz Q2 initial. So this is quiz 2 initial. So 50, 41, and 42. So it says that for quiz 2, marks were given
Plus 2.
Q2 bonus was given as 10, 12, 15. So Q2 final, Q2 new updated or final, okay, final, initial final. So this would be
60.
50, 41. So Q2 initial plus Q2 bonus.
Okay.
10, 12, 15. So this would give you 60, then 53, and 57. Okay.
Yes.
Okay. So so that's all for quiz. Sorry, activity 1.1. Then activity 1.2. Please list all your doubts. Okay, so tell me what all doubts you have in 1.2. uh, am I audible or not?
Yeah,
Yes, sir.
you're audible.
Okay, so tell me what all doubts you have in activity 1.2.
Hi, actually, I am repeating this Max 2 course. Should I have to again resubmit all the assignments?
Yeah, that depends. If you have opted only for end term appearance, then you would only have to appear for end term. Okay. But
Okay.
if you have opted for repeating full course, then you would have to resubmit the assignments. Okay, so it would be better if you can speak rather than typing in the chat box. Okay.
So question number 6 from activity 1.2.
Okay. Okay, fine. Question number 6. Then
Question number 9.
And question number 8 also, sir.
9, 8. Okay, fine. Then question 6, 8, 9. Okay. Okay.
Question 10.
Fine. Question 10. Okay. So I'll start from question number 1. If any question is good, then I'll explain that also. Okay. So 1 is easy. Okay. Then second is easy. Then third is also easy. Then we have fourth question. Okay. Yeah, that is also trivial. Then fifth is trivial. Okay, sixth question. Okay, so sixth question is a good one. So let's start with sixth question. So choose the set of correct options. It says that for the first option, if A is a square matrix, it's of order 2 cross 2 and A square is equals to identity matrix, then A is equals to I or A is equals to minus I, where I is identity matrix. Okay. So first of all, see this part states that if A square is equals to I, that is identity matrix, then A can be only I, that is identity matrix, or negative or identity matrix. If on solving this, if you find any other example where this thing satisfies, but it is not any of these two, then you would say that this statement is false. Okay. So basically, this is a proposition. Okay. So this is taught in discrete maths, but just know that if this states something, okay, this is stating that a square is equals to I, then A should be only one of these two. Okay. It cannot be anything else. If you are able to find any other, then you would say that this statement is false. Okay. So any doubt in this? So see,
No, sir.
P implies Q. Okay. So this is if this thing is true. Okay. Then if you are able to prove this thing as false, then this whole statement becomes false. Okay. So let me draw the table for P implies Q. Okay. You need not worry about this, okay? But you can look it up. So, any doubt in this?
No, sir.
Okay. Okay. Fine. So I'll get to it then. So let's take for simplicity A, B, C, D. One tip is there that you should avoid taking example matrices as this because it makes it very difficult to solve, right? So just take simple terms. So in hint, it has been given A11, A12, A21, like that. So you can just take this. Okay, so let's start solving this. So it says that A square is equals to I. So first of all, let's write A square. Okay. So I'll quickly multiply this. Okay. A square plus BC. Then you have AB plus BD. Then you have AC plus CD. Then you have BC plus D square is equals to identity matrix. Okay, so let me recheck it once again. A square plus BC, AB plus BD, then AC plus CD, and CB plus D square. Fine. So see, now you have an equation representing the equality of two matrices. So you would equate the terms at the same positions. So you will get A square plus BC is equals to 1. Okay. Then this term with this term, you will have AB plus BD is equals to 0. Then this term with this term comparing. Okay. AC plus CD is equals to 0. And then you have BC plus D square is equals to 1. Now see, you have four simultaneous equations. Okay. So this is a system of four equations, and you need to find values of A, B, C, and D, which simultaneously satisfies all four equations. Are you getting this? You have to find these four values to find our original matrix. Then only we can check whether it is equal to only identity or negative identity, right? Okay, so emphasis is on the simultaneous term. Okay, simultaneously is very important. Okay, then yeah, so see, I can take this equation and this equation because it has BC term common. So what I will do first, I will okay, so taking equation 1 and 2. Okay, so A square plus BC is equals to 1 and 4. Equation 4 now, equation 4, D square plus BC is equals to 1. Now I will subtract fourth equation from first equation. Okay, so basically I will subtract this equation from this equation. Okay, so these two terms will cancel. You will have A square minus D square is equals to 0. Okay, 1 minus 1. So basically you will get A plus D, A minus D is equals to 0. Now, see, now this means that A plus D is equals to 0 or A minus D is equals to 0. So now this thing implies that A is equals to minus D, and this thing states that A is equals to D. Now you have two cases. So this is case 1 and this is case 2. Is everyone following what I am doing here?
Yes, sir.
Yes, sir.
Okay. Okay, so we will explore these two cases. So first I will explore this case one. Okay, so now I will utilize the rest of the two equations. So I will put A is equals to minus D in these two equations and see whether we can get somewhere. Okay. So it states that AB plus BD is equals to 0 and AC plus CD is equals to 0. Okay. AB plus BD equals to 0 and AC plus CD is equals to 0. Okay, so now you substitute A is equals to minus D in both these equations. So okay, so A, okay, okay, so okay, so let's substitute minus D, okay, in place of A, B plus BD is equals to 0. So this is minus BD plus BD is equals to 0. So this is 0 is equals to 0. So this is of no use because it does not give us any result. Now again, similarly, you will get minus D C plus CD is equals to 0. So minus CD plus CD is equals to 0. Again, 0 is equals to 0. So we did not reach anywhere from this case, okay, using this case. So now let's see the other case. A is equals to D. Again, we will use these two equations. So AB plus BD is equals to 0. Substitute A is equals to D. So you will get BD plus BD is equals to 0. So you will get 2BD is equals to 0. And in second equation, AC plus CD, again substitute A is equals to D. So you will get CD plus CD is equals to 0. So 2CD is equals to 0. So this implies CD is equals to 0 and here BD is equals to 0. So now, okay, so you have BD is equals to 0. So when does this LHS become 0?
When either one of them are 0?
Yeah, it could be that B is 0 while D is not equals to 0. Okay, this is one case, case 1. Then it could be the case that B is not 0 and D is 0, right? Yes or no?
Yes, sir.
Anyone? Okay. And it could be the case that both are 0. Yes or no?
Yes, sir.
Okay. So similarly, here also, it could be the case that C is 0 while D is not 0. C is not 0 while D is 0. Or it could be the case that both are 0. Okay. So now, again, we are solving it simultaneously. So see, now according to these two equations, we get 9 cases. So see, you have 3 here and 3 here. So for each case, okay, so for this case, you have 3 possibilities for C, right? So you basically will have 9. Out of these 9, most of them will be absurd because see, B is 0 while D is not 0. Can you pair it with this? C is not equals to 0 while D is 0. So these two will be contradicting, right? So out of those 9 cases, you will have most of the cases already eliminated. So let's see one example. Okay. Okay.
Sir,
Yeah.
sir, actually I want to ask why we do this. Means what's the motto behind this?
Behind what?
behind this calculation means what we are trying to get.
See, we are trying to find a counter example to this proposition. It states that if this thing is true, then you can have A as only these two matrices, that is identity or negative identity. So basically, I have assumed a matrix, okay, matrix. Then I'm trying to find what all possible matrices I can get for A. That's why I'm trying to find A, B, C, and D. Okay, so are you getting that?
Yes, sir. Yes, sir.
So if I am able to find any counter example, then I would state that this is false. Okay, this
Okay, sir.
statement. Okay, so let's see. You will see that we will find counter example for this. Okay, see in exam it is sometimes it is very difficult to find counter example right off the bat, right? You could get lucky with some example, okay, but mostly you are not able to find a counter example. So this is the systematic procedure to find a counter example. Okay. Okay. So 9 cases. So B is equals to 0.
Sir, can we expect such kind of questions in the paper?
Yeah, mostly not. Okay. So these are for practice. But mostly these types of questions are not given. Again, I am not the one setting the paper, so I cannot tell you for sure.
Oh, okay, got it. Thank you.
Yeah. Okay. So is this clear how we are getting 9 cases? So out of those 9 cases, most of them will be absurd because see, let me write one case. B is equals to 0, D is not equals to 0, then C is not equals to 0. Okay, this I'm pairing this one with this, and it states D is 0. So these two are again contradicting. So this case will get eliminated anyways. Okay, so let's see. Yeah. Okay, so let me. Okay, B is equals to 0. T is not equals to 0. So I'm pairing this one with this. Not 0. C is equals to 0. Okay, I'm not writing this again. Okay, and this is under the A is equals to D case. So you have A is equals to D. Okay, so you have this. So again, we will use the 4 equations given to us. A square plus BC is equals to 1. So you have C as 0. So let me use the first equation. Right, this is the first equation. So if you substitute C as 0, this term will become 0. So you will have A square as 1. Okay, so you will get A as plus minus 1. Then D is equal to A. So again, you will get it as plus minus 1. Then B is 0 and C is 0. Okay, so okay, one more thing. When A, okay, let me write the A matrix. So it was A, B, C, D, right? A, B, C, D. And you have, so okay, so let me write. A is 1. When A is 1, D is also 1, right? And B and C and are 0. So you can see that it is indeed the identity matrix, okay? And if A was minus 1, you can see from here, okay? Minus 1. So D will also be minus 1. And B and C are 0, 0. So this is negative of identity matrix. So I was not able to get a counter example in this case. Yes or no?
Yes, sir.
Okay. So again, I paired this case with this one. So I did not get any counter example. This one will get eliminated because it states D is not equals to 0 while this state D is 0. Then again, similar case here. So I will jump on to case 2 on this side. So B is not equals to 0 while D is 0. Okay. So yeah, B is not equals to 0 while D is 0. Again, if I pair it with this one, again this will contradict each other. So I cannot pair it with this one. Then this with this, C is not is 0 and D is 0. C is not equals to 0 and D is 0. I'm not writing that again. Okay. And this is under the A is equals to D case. So you have A is equals to D. Now, let's again use the equation number 1. A plus BC is equals to 1. Right? This is equation 1. So B is not 0 and C is not 0. Okay. Then you have A square. Okay. So this will not give us anything. So we will
Sir,
use.
D is equals to A equals to 0.
Yeah, sorry. Yeah. Thanks, Gopal. Yeah, so yeah, A is also 0. Yeah. Okay. So this will be 0 plus BC is equals to 1. BC is equals to 1. Now it states that B is not equals to 0, C is not equals to 0. Okay. So B and C are real numbers. So what I will do, I will represent it as B is equals to 1 by C. Okay. So now I will write the A matrix. So A is 0. Okay. So let me write the general form. So A is 0 and A is equals to D. So D is also 0 and B is 1 by C and C, where C is any real number. Okay, minus 0. Okay. Minus 0 because it states that C is not equals to 0, right? So you can see that if I suppose, let me take an instance. So 1 by 5. Okay, I'm taking C as 5. So I have got this matrix. Now, is it an identity matrix?
No.
Okay, so let's calculate A square. Okay, if A square indeed comes to be equal to identity matrix, then you will say that yes, we have found the counterexample and the given statement was actually false. Okay. Okay, so 0, 0. Okay, so 0 plus 5 dot 1.5, then 0 dot 1.5 plus 1.5 dot 0, then this row with this column. So 5 dot 0 plus 0 dot 5, then this row with this column. So 5 dot 1.5 plus 0. So what are you getting? You are actually getting identity matrix. Yes or no?
Yes, sir.
So you saw that A need not be only identity matrix to satisfy this A square is equals to I. So see, it is saying that if A is a square matrix of order 2 cross 2 and A square is equals to I, then A has to be one of these. But you found that it could be this also. Okay. That is, it could be this also. And this condition is getting satisfied. So that statement is false. Okay. Any doubt? Any doubt?
No, sir.
Anyone? Any doubt? Okay. So we'll jump on to the next question. Eight. Okay, sorry. It is not yet completed. Okay, so sixth question says that, okay, again, it is very similar. Second option of this. Okay, so again, it is very similar. Instead of identity matrix, here you have 0, and it is saying that if a square matrix of order 2 cross 2 satisfies this condition, then it can only be the 0 matrix. Again, if we are able to find a counterexample such that square of that matrix is equal to the 0 matrix, then we will say that this statement is false. Okay, so
0, 0, 0, 1. Matrix
yeah,
of 0, 0, 0,
see,
1.
you can definitely try the hit and trial method. Okay, and if that doesn't work or you are not able to come up with such counterexample, you can follow this same procedure. Okay, so here we have 0, 0 in second option. So you can use either of these two methods. Okay. So yeah, which example? What was the matrix instance you were telling? Someone
0,
was
0, 0, 1.
0, 0, 0, 1.
1.
Yeah, yeah. This is fine. Okay. So see, you will get 0, then you will get 0, and you will get 0. No, no, you are not getting a square as 0.
I think my bad. I think. Okay.
Okay, so okay, we will see counter example afterwards. First, let me do the procedure. Okay, so yeah. So again, I will do this quickly. Okay, it is very similar to the first option. Anyone have any doubt in the above option which I just solved?
No, no, sir.
Is that clear?
Yes, sir.
Okay, fine. So I calculated the A square matrix. Okay, so this is the A square, and it is equated to 0 matrix. So A square plus
So,
BC is equals, yeah,
so can it be 0, 1, 0, 0?
0, 1, 0, 0. Okay, okay. Let me write it. I will come back to this. 0, 1, 0, 0. Fine. Okay, so D square plus BC is equals to 0. Then you have AC plus CD and AB plus BD. Okay, so again you have four equations. You have to find the values of A, B, and A, B, C, and D, which simultaneously satisfy these four equations. Okay, so I will use equation 1 and 2 again. Okay.
Again, A is equals to plus or minus D.
Yeah. So I'm writing it directly. Okay. So A square minus D square will be equal to 0, and you will get A plus D, A minus D is equals to 0. So you will get A as minus D, A as plus D. Okay. So you have take two cases. Now again AC plus CD is equals to 0 if you substitute A as minus D. So you will get minus CD plus CD as 0. So 0 is equals to 0. So you will reach nowhere. Again, you have to jump onto the second case. Okay. If you use the second equation also, again, you will get nothing here. BD plus AB is equals to 0. So minus BD plus BD equals to 0. So 0 is equals to 0. Okay. So now A is equals to D. Okay. So okay. So what you will use is AC plus CD is equals to 0. So you will get 2 CD is equals to 0. It is actually same till here, right? Same as the above option. And you will get 2 BD. Okay, let me write. AB plus BD is equals to 0. So you will get 2 BD as 0. So BD is equals to 0. Again, you will write those cases. Okay. Okay, so C is equals to 0, D is not equals to 0. C is not equals to 0, D is 0. C is equals to 0, D is equals to 0. And here B is equals to 0, D is not equals to 0. B is not equals to 0, B is equals to 0. Or you can have B as 0 and D as 0. Okay. Okay, one more thing. You can go further and solve for these cases also. But since we already found a counter example, I need not go any further. That's why I stopped at this point, right? Okay. Yeah. So again,
Sir,
yeah.
sir, C is not equal to 0 and D is not equal to 0 can also be okay.
How? Can it be?
Only one
Tell
of
me.
them should be 0.
Only
Okay.
these three cases are possible for CD to be 0, right? Okay.
Okay, then the counter example can be 0, 1, 0, 0.
0. Yeah, yeah. We will get to that, but let me first complete the procedure, right? Sometimes you may not be able to come with counter examples during the exam, so you can use this procedure. I'm just telling you how to do it. Okay. So again, you will have 9 cases. Out of those, most will be absurd. Okay. So some will be right. Okay. Now let's see. C is 0, D is not equals to 0. Okay, so let's see this one. C is equals to 0, D is not equals to 0. So I'm pairing this one with this one, and D is 0. Okay, so this is first case. So now I will use the first equation, A square plus BC is equals to 0. Okay, so you will get A square and you have A is equals to D. So A is equals to D equals to 0. Okay, so A is also 0. So again, you have 0 is equals to 0. Sorry, this was not equals to 0. Sorry. Yeah. So A square is equals to 0. So you will get A as 0 and you will get D as 0 because A is equals to D. So you are indeed getting A as the 0 matrix. Okay, so we were not able to find counterexample in this case. So now we will see any other case. C is equals to 0, D is not equals to 0. Okay, so it will not get paired up with any of the other two. So let's use this one. C is not equals to 0. D is equals to 0. Pair it up with this one. Okay, so you cannot pair it up with this one because here D is not equals to 0 while here it is equal to 0. So let's pair it up with this one. Yeah. D is equals to 0 and B is not equals to 0. And you have A is equals to D. Okay, so you will get A as also 0. So A square plus BC is equals to 0. Okay, so you will get BC as 0. Okay, now again you will solve this has 3 cases. Okay, so let's take first case. So B is 0, C is not equals to 0. Okay, so C could be any real number other than 0. So you have, let me write the matrix. So you have, see, this was under the case, this case, right? Okay. So, yeah. So first of all, see that B here is equal to 0 and it is under this case. So this will be contradictory. Okay. So all these 3 cases are actually contradictory because it states that C is 0. Okay, while this states that C is not equal to 0 and these two states that they are equal to 0. Okay, so no useful case here. Okay, so we have to again jump back to this. Okay, so C is not equal to 0, D is 0. Yeah, so let's pair this with this one. Okay, so this is very lengthy actually. So C is not equal to 0, D is 0. Is everyone following what I'm doing?
Yes, sir.
B is 0 and D is 0. Okay, and A was equal to D. Okay, so now I have to check this case. So basically is 0. Okay, so if I write the matrix now, okay, because we will not use any equation because we will not get any useful result because we already have all the useful cases here. So this would be C, 0 plus 0 would be 0. Okay, so we have all the 4 terms. So A is 0, B is 0, C could be anything, and D is 0. So let's see whether this A square is actually equal to 0. Okay, so we will check that. So this will give you 0. Okay, this row with this column, and then this row with this column. So 0. Then this row with this column, 0. Okay, then this row with this column. So you can see that our A matrix can be this matrix, which is not equals to 0 matrix, and still A square is equals to the 0 matrix. Okay, so you have again found a counter example. Is this clear?
Yes.
Is this clear? Are you able to get how I'm?
Sir, can you explain the last step? A square one.
This one?
Yes, sir. The last step. Yes, sir.
Okay, so are you clear with the matrix multiplication?
Yes, sir.
So see, okay, let me write it completely. So see, this I will use this row multiplied with this column. Okay, so 0, 0 dot 0 plus 0 dot 5. Okay, then now this row with this column. Okay, so 0 dot 0 plus 0 dot 0. Then this row with this column and this row with this column. So now 5 dot 0 plus 0 dot 5. Okay, now this row with this column. So 5 dot 0 plus 0 dot 0. So this would be 0, 0, see 0 plus 0, 0, 0 plus 0, 0 plus 0. So this is dot, not decimal again. Okay, so this is multiplication, not decimal.
Yes, I got it.
Okay, so 0, 0. So yeah, so this was it. You found a counter example. Okay, so now back to this. Someone told me this instance with hit and trial. Okay, so let's see whether this is actually equal to a square is actually equal to 0. Yeah, so this is indeed a counter example found by hit and trial. Okay, okay, so yeah, so B option is also wrong because you found a counter example. Then yeah, uh, is my pace fine with you all, or am I moving too fast?
No,
No,
sir,
sir.
it's right.
Okay, so C option states that if A plus B, where A and B are square matrices of order 3 and A plus B is equals to 0 matrix. Okay, so this is 0 matrix because you have matrices on the left hand side. So this is obviously a 0 matrix. Okay, not the real number 0. Okay, so B would be minus A. That is correct. Nothing to solve here. Then D option. Okay, so yeah. Yeah. Okay, so it states that if, okay, I'm not writing the question. Okay, A is a scalar matrix of order 3, fine. B is a non-zero zero matrix of order B, fine. It states that if AB is 0 equal to 0, then A is equals to 0. Okay, so in short, it is written this. If AB is equal to 0 matrix, then A should definitely be 0 matrix. That is, this scalar matrix should actually be the 0 matrix. Now again, you have to use the procedure. So first of all, A is a scalar matrix. So let me write it as this. Can I write it like this? Tell me.
Yes, sir.
Fine. Okay. So let's check. So ki into b is equals to 0. So you know that multiplication of a matrix with an identity matrix of same order will result in the original matrix itself. Okay. So wait a second. Then a is 0. Yeah. Okay. One more thing. We have to write instance of b also. So let me take the simplest non-zero matrix. So basically any matrix which has even one element which is not zero will be a non-zero matrix. So let me take this b 0 0 0 0 0 0 0 0. Okay, so is this a non-zero matrix?
Yes.
Okay, so b is not equals to 0. Okay. Yeah, so b is not equals to 0. Okay, b belongs to real number. Okay, so this is a non-zero matrix. Okay, so let's multiply this. Okay, so I into b would give you b itself. Okay, so now k is a scalar. Okay, so k is a scalar and this is a matrix, right? So let me write b matrix again. Okay, so on multiplying a matrix with a scalar, every element of the matrix gets multiplied with the scalar. Okay, so now this is equal to the zero matrix. Okay, as this proposition states. Okay, so now you have to equate. Okay, kb is equals to 0. Now, according what was given, that b is a non-zero matrix, right? It is a non-zero matrix. Basically, b is not equals to 0. Yes or no?
Yes.
So
Yes.
this statement states that kb is equals to 0. So when b is not equals to 0, this implies that k must be 0. Yes or no?
Yes.
Yes.
So our original matrix A was actually 0 times identity matrix. So it was indeed a 0 matrix. So no counterexample could be found. So that option is correct. Are you getting this?
Yes, sir.
Okay.
Sir, excuse me.
Yeah.
Sir, where can we get the recording of this session?
Yeah. I have. I had already told you previous, not you, but someone that I will post the link. Okay, it will basically be available on YouTube. I will post the link after the end of the session or most probably tomorrow.
Okay, sir.
Okay, so you could have taken any other complex non-zero matrix also, but I took the simplest example. If you had taken all elements as B, okay, which were where B is not 0, then also you would have seen that here you would have to equate KB, 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 KB is equals to 0, 0, 0, and you will get the same result. Okay, so okay, fine. So eighth question. Okay, so we have completed sixth question we have completed. Yeah. Okay, so eighth question now. Okay, have you seen seventh question?
Yes.
So see, that question is actually important because it tells you the different ways to multiply two matrices. Okay, so that question is actually good. Okay, that is actually a standard result. So we will get back to that after I have taken all the doubts. Okay, so just make a note of question 7. It is good. Fine.
Okay, sir.
Okay.
Sir, excuse me.
Yeah.
Sir, the fourth option of question 6 we have just discussed. So in the question is given A is scalar matrix of order 3.
Yeah.
Then out of this we get A is 0. So is the 0 matrix is scalar matrix?
Yeah. See, scalar matrix says that any diagonal matrix which has all the diagonal elements which are same. Okay, it does not restrict any condition on the elements not being 0. So it states that all the elements below the diagonal are 0 as well as above the diagonal are 0 because it is a diagonal matrix. Okay, so all these elements are 0. These are 0. And scalar matrix is a diagonal matrix for which all the elements on the diagonal, leading diagonal, okay, this is leading diagonal, this is not the leading diagonal. Okay, there are two diagonals in here, but we usually talk about the leading diagonal. So it states that all the elements on the leading diagonal should be equal. Now if all the elements are 0, then in that case all the elements on the diagonal are indeed 0. So 0 matrix is also an instance of scalar matrix. Are you getting this?
Yes, yes.
Hello?
Yes,
I thought I was told that it is represented as K times identity matrix, and there no condition given on K, so I thought
K belongs to real number.
0. Yeah. Oh, okay.
Okay. So see, I've written here.
Yeah.
I've written here. K belongs to real.
Oh, yeah.
Real also includes
Okay,
0, right?
Yes, yes, yes. Fine.
Okay. Yeah. So make a note of question number 7. It is good because it is a standard result and it usually helps you to multiply two matrices quite easily. Okay. Usually we multiply a row with a column, then with other column, with other column. So if you are not proficient in this, then you might do some mistakes, but those results given in option 7 are usually quite helpful. Okay. Yeah.
So in that, I didn't understand that question. C1 is the entire column which consists of two elements, no?
Yeah. See, I will do one thing. I will get back to that question after the session.
Okay, sir.
Okay. Because, but it is a good question because it usually is stating a standard result to multiply two matrices. Okay. So we were on question number 8. Let me check. Yeah. Question 6. Yeah. Okay. So 8th question. Okay. So first option states that there exists. So this is the symbol for there exists. Okay. In short, some real matrices such that AB is equals to BA. So you must have seen the property which states that AB is not always equal to BA.
Yeah, except
Okay.
for
In
identity.
yeah. So see, this means that not equivalent. That see, if you say that AB is equals to BA, sorry, this double implication, then it states that in every possible case, AB will be equal to BA. And this, see, I've drawn a vertical line here. So this states that AB is not always equivalent to BA. It could be in some cases, okay? When it is written like this, equivalent, that means in all cases, AB will be equal to BA, okay? You can find examples for that, but this is a standard property, okay? So AB is not always equal to BA. In some cases, it could be, okay? So A option says that there exists some real matrices. So there exists means that even if one matrix exists where AB is equals to BA, then this option would be correct, right? So first option is actually correct. Anyone have any doubt in this option?
So can you repeat it again, sir?
See, there exists means that if you can find even one example where AB is equals to BA, then this whole statement will be true. Okay, but if it was written for all, then this statement, then that means that for all the possible matrices in the world that you can find, this should always be equal to this. Okay. Have you been taught? Okay, I think it was taught in Maths 1. There exists and for all, but I'm not sure.
Yes, sir.
But there exists means that you just need to find even one example. If you are able to find one example where this holds, then this statement will be true. But if you are not able to find any example, any matrix, then this statement will be false. Okay, so you just need to find one instance. But
Sir,
when,
if I
yeah,
sir, I want to say if I take A equals to 0 matrix and B is also 0 matrix, then the product of both the matrices equals to AB equals to BA. So this is correct. So that's why this statement is true.
this statement is true. Yeah,
Hmm.
you can
Okay,
find other examples also, but there are cases where AB is equals to BA. Okay, so there exists means you need to find one example out of all the matrices possible. So this is correct, first option. Okay,
Sir, uh, like
but
A
if
is equal to I
yeah,
and B is equal to minus I.
A is equals to I and B is equals to minus I.
Yeah.
Okay. Okay, so this would be -1. This would be 0. This would be 0. This would be -1. This would be -1. This would be 0. This would be 0. This would be minus. Yeah. So yeah, you can see that for A is equals to identity matrix and B is equals to negative of identity matrix, AB is indeed equal to BA. Okay. So basically, commutativity does not hold for matrices. Okay. In when I say that commutativity means that if you rearrange these, like if you bring B here, then it should be equal to AB. But you can see that it does not hold in all cases. So when if commutativity was being held in all cases, then you would say that AB matrices are matrix multiplication is commutative. But it is not the case. You can see that. Okay. Okay. Then uh, yeah. So there do not exist second option. Uh, anyone have any doubt in this?
No, sir.
Okay, so this is basically commutative law. It does not hold for matrix multiplication. Because see, one more obvious thing. If A is a 3 cross 3 matrix and B is a 3 cross 1 matrix, then you will see that in this case AB is defined. But if you go on finding BA, then you will see that 3 cross 1, 3 cross 3. This is not even defined, right? Yes
Right,
or
sir.
no? So therefore,
Yes.
commutativity does not hold for matrix multiplication. Okay. Yeah. So second option states that there does not exist any real matrix A and B, matrices A and B, such that AB is equals to BA. So that is not the case because we indeed found two matrices, okay, for which AB was equal to BA. So second option is wrong. Okay. Okay, let me write it nicely. Okay. So there exist matrices A and B such that AB is equals to BA. So B option is incorrect. Okay. Then D option, C option. There does not exist any real matrix A such that A square is equals to A. Very simple example from the top of my head is A as the identity matrix. So for identity matrix, you will get identity matrix itself. So, okay. So again, C option is wrong. Any doubt in this?
Sir, can it be generalized to n?
Can we generalize to?
N, like a power n is equal to I power n is equal to I.
Yeah, yeah. If you keep on multiplying identity matrices, you will end up with identity matrix itself. Okay. So any power of I will be equal to identity matrix itself.
Okay.
Okay. So how many of how many? So okay. Is anyone having any difficulty in understanding whatever I'm explaining?
No, sir.
Okay. Fine. Okay, so D option. There exists some real matrices, some real matrix A of order 2 cross 2 such that A square plus A plus I. Yeah, again, this is a very lengthy question. Okay, so let's solve it. So I think the problem must be arising in this option, right? Whose doubt was it? Question number 8.
My doubt,
Yes,
sir.
sir.
I have problem in option one only.
A
No,
problem in
option two only.
option 2 only. Were you able to solve D option? Okay.
D option, yeah. B and
Okay,
D.
so for B option, you saw that we were able to find counter examples where
Yes, sir.
AB was actually equal to BA. Okay. So that means that option D is incorrect. Now D option. Okay, so did you also have a problem in D option?
No, sir.
Okay. Anyone else had a problem in D option?
Sir, I had problem in D.
Okay. So again, you can try to find counter example, but that is usually not possible. So we will see the procedure for that. Okay. Okay. So yeah. So pay attention to this one. Okay. So let's take A as A, B, C, D. Okay. Simplest example we can think of. Okay. Okay. So A square plus A plus identity matrix is equal to the zero matrix. So its question is saying that there exists some real matrix A such that A square plus A plus I is equal to zero. That is, if you are able to find one example or one instance of such A matrix, then this option would be valid. Valid means true. Okay. So let's solve. So first of all, I will write A square and then I will substitute. Okay. So A square would be same as which we calculated earlier. A square plus BC, AB plus BD, then AC plus CD. Then you have BC plus D square. Okay. So this is the same matrix A square which we got in earlier examples. So we will substitute A square in this equation and rest of the matrices also. So A square plus BC, AB plus BD, AC plus CD, BC plus D square plus A matrix A, B, C, D plus identity matrix, okay, is equals to zero matrix. Okay, so just add these three matrices at once. Okay, so A square plus BC plus A plus 1, then AB plus BD plus B, okay, plus 0, then AC plus CD plus C plus 0, okay. So need not write that. Then is my voice audible? Is it clear?
Yes, sir, it is clear.
Okay. So BC plus D plus 1. So yeah, we are getting this and we are equating this matrix to this matrix. So just equate the elements, okay? So again, you will get 4 simultaneous equations, okay? 4 equations which need to be solved simultaneously for the values of A, B, C, and D. Yeah. So B square, I'm writing this equation, B square plus BC plus D plus 1 is equal to 0. Then I'm writing this equation. AB plus BD plus B is equal to 0. Then I'm writing AC plus CD plus C is equal to 0. Now, okay. So see, just quickly scan all the equations. Okay. You can see that this equation has B term common and this equation has C term common. While these two equations don't have that much in common. Okay. So what I will do, I will start with these two equations. Okay. So first of all, I will take B common from this equation. So 1, 2, 3, 4. Okay. So equation 3, B as common. So it would be A plus B plus 1 is equals to 0. Okay. So again, this will mean that B is equals to 0 or A plus B plus 1 is equals to 0. Similarly, for equation 4, I will take C common. This would become A plus B plus 1 equal to 0. So C is equal to 0 or A plus B plus 1 is equal to 0. Okay, so B is equal to 0. A plus B plus 1 is not equal to 0. Oh, I'm writing this more elaborate in an elaborate manner. Okay. B is not equal to 0. A plus B plus 1 is equal to 0 or B is equal to 0 or okay, yeah, A plus B plus 1 is equal to 0. Okay, then C is equal to 0. A plus D plus 1 is not equal to 0. C is not equal to 0. A plus D plus 1 is equal to 0. B is equal to 0. A plus B plus 1 is equal to 0. Okay. So again, you will form cases. Okay. Okay. So let me form first case. So B is 0, A plus D plus 1 is not equal to 0. I will pair it up with this one. Okay. So okay. So now sorry. Okay. So I will use I will use first equation. A square plus BC plus A plus 1 is equal to 0. So B and C are 0. So this equation would become A square plus A plus 1 is equal to 0. Okay. So now, if you see, the discriminant of this quadratic equation is actually less than 0. Yes or no? Tell me.
Yes, its
Okay,
root
so
would be imaginary.
yeah. So B square minus, okay, not B square. Okay. So discriminant is less than 0. This implies A is imaginary. Now, if you see the question carefully, you can see that the proposition states that A is a real matrix. But if you are getting A as imaginary, then that matrix will no longer remain a real matrix. Yes or no? Tell me.
Yes.
Is everyone else also getting this? Okay. See, please try to respond. Otherwise, I wouldn't be able to get whether you are able to understand or not. Are you getting this? So, as you saw that A is coming out to be imaginary, I can stop here. Okay. I need not to go further because A is coming to be imaginary. Okay, so this case is of no use. Now I will move to other case because I need to find a real matrix. But A is coming to be imaginary. That will render my matrix to be not a real matrix. So uh, I hope you are getting what I'm trying to say. Okay, so I will jump on to next case. Okay, so you need to check all the cases one by one, and you need to find one instance of a real matrix. Okay, if you are able to find one, then you will say that yes, my option is correct. Okay, so let's move on to uh, okay, so I paired this case with this. Then this would not make sense because these two are contradictory. Then again, I cannot pair it this one with this one. Then I will jump onto this case. B is not equals to 0. A plus D plus 1 is equals to 0. So I will try to pair it up with this one. Again, not possible. Then this one, yes, this one is possible. B is not equals to 0. C is not equals to 0. And A plus D plus 1 is equals to 0. I hope you are able to get how I am getting to each of these cases one by one, right? And eliminating those cases. Okay. So now I will again use the first equation. Okay. So A plus D plus 1 is 0. Okay. So what I will do is I will use this one, this equation. A plus D plus 1 is equals to 0. Okay. And I will A plus 1, I will collect these two terms and send the D term to the RHS. Okay. So I will use the first equation. So I will substitute A plus 1 with minus D. Now I will use the second equation, which is D square plus BC plus D plus 1. Now I will collect these two terms, D plus 1 minus A. Okay, and I will substitute D plus 1 with minus A. D square plus BC minus A. Okay, so I have got these two equations now. So what I will do, I will subtract this equation from this equation. A square plus BC minus D square minus BC plus A is equals to 0. Okay, these two terms will cancel. Then you will have A minus D. So A square minus D square will give you A minus D, A plus D. Then plus A minus D is equals to 0. So A minus D, this term. Then I will take A minus D as common. A plus D plus 1 is equals to 0. Again, this thing was already given to us in under this case. Okay. So now you could have, again, you could have two cases. So A is equals to D or A plus D plus 1. Okay, sorry. Not entirely wrong, but yeah. A minus D is equals to 0 or A plus D plus 1 is equals to 0. Okay. So, okay. So let's see this case. Okay. A minus D is 0. That means A is equals to D. Okay. Okay. So now I will use the rest of the equations, which is AB plus BD plus B is equals to 0. Okay, so A is equals to Z. So I will substitute A in that equation. So our equation was AB plus BD plus B is equals to 0. So I will substitute A. So you will get BD plus BD plus B is equals to 0. So you will get 2BD plus B is equals to 0. So you will get B common. So 2D plus 1 is equals to 0. So now again, B could be 0 or D could be minus 1 by 2, right? Yes or no? Okay. So now these, anyone wants to say anything? Okay. So now I will use the second equation. Not second, fourth, I think. Yeah, fourth equation. AC plus CD plus C. I will substitute A. Okay, so you will get CD plus CD plus C is equals to 0. So again, you will get 2CD plus C is equals to 0. So you will get 2D plus 1 is equals to 0. So you will get C as 0 or D as minus 1 by 2. Okay. So, okay. So you are getting A is equals to D. So D is minus 1 by 2. So you will get A as minus 1 by 2, D as minus 1 by 2, B as 0 and C as 0. So if you now write the original matrix which we used, you will get minus 1 by 2. Okay, I think I did some mistake there. Okay. So minus 1 by 2, 0, 0, minus 1 by 2. So let's see whether we are getting the answer. Okay, yeah, I did a mistake here. Okay, so see, we are operating under this case, right? And it's stated that B is not equals to 0. So this wouldn't make sense. So we cannot take B as 0. So this would mean that D is minus 1 by 2 and B is not equals to 0. Yeah, I forgot that. Okay, so B, this is not correct. Okay, because we have worked under this case. We had taken B is not equals to 0. So this means that D will be equal to minus 1 by 2. Okay, so this thing is not correct. That, see, B into 2D plus 1 is equals to 0 means that this could be 0 or this could be 0 or both could be 0. But you have seen that we had taken this case where B was not equals to 0. So this means that D will be minus 1 by 2. So this term will be 0 while this will not be equal to 0. Okay. So now, yeah. Okay. So again, C is also not equals to 0. So this would mean that C is not 0. That is D was equal to -1/2, making this term to be 0, and C was not 0, because we are again working under this case. So now we know the values of A and D, because A was equal to D under this case. Okay. Yeah, under this case. So A was equal to D. So now we have found two values. We need to find B and C. Okay. So to find B, we would have to use okay. To find B, we would have to use one of the equations. So which one should we use? Yeah, we can use this equation, the third one. AB plus BD plus B is equals to 0. AB plus BD plus B is equals to 0. So now substitute this. So minus B by 2 plus D is also minus B by 2 plus B is equals to 0. So this will give you minus B plus B. So we will reach nowhere. Okay, so no use of using this equation. So we would have to use similar case will happen in this. You will get 0 is equals to 0. So we will have to use this equation. Okay. So yeah. So A square plus BC plus A plus 1 is equals to 0. Okay. So substitute -1/2 in place of A, you will get 1/4 because it is a square. Okay. Then plus BC. BC plus A minus 1/2 plus 1 is equals to 0. Then you are getting this would be -1/4 plus BC plus 1 is equals to 0. So this would be 3/4. Okay. So is this correct? 0.05 minus 0.5 minus 0.5 plus, yeah, 3/4. So you are getting BC is equals to 3/4.
Minus 3/4.
Yeah, sorry, minus 3/4. Okay, so A plus D plus 1. Okay, so B, okay. So B you can write as minus 3/4 C. Okay, because C is not equals to 0. Okay, so now we have found all the required elements. So you will get A as -1/2 minus 3/4 C. Here you will get C, and here you will get -1/2. Now you need to put any value of C from the real numbers except 0. So you will get, suppose I take C as 1. Okay. So you will get -3/4. Then you will have a 1, and you will have -1/2. Okay. So now you need to substitute it in this equation. Okay. So yeah. So I have to do the matrix multiplication. -1/2 -3/4 1 -1/2 plus A 1 -1/2 plus identity matrix. Okay, so let me quickly check whether it is actually coming to be equal to 0. Meanwhile, you can try to solve this and check whether it is actually coming equal to 0. Okay, so -0.5. Did anyone check this? Anyone?
Sir, it will take time now.
Yeah, okay, so let me check. Okay.
Yeah, so getting 0.
Okay, so you are getting 0, right?
Yes, sir.
Yeah.
Okay, fine. So uh, now tell me, is this matrix actually? Oh, sorry. You can see that this is a real matrix. Okay, so you were able to find one instance of such matrix for which, so there exists A is equals to, for which A square plus A plus I is equals to 0. Okay, so
So
yeah,
is this like the unique solution we have found for these four
no,
equations?
see,
Or
you can see that here C is a scalar, right? C is a real number except 0. So you can just keep changing C and you will get all such matrices for which this is equal to this. So you had to find only one instance. So if you are able to find one instance, then you can say that the given proposition is true or given statement is true. Okay. So this took quite a lot of time. Then we have, okay. Yeah. Okay, so I'll quickly complete activity 1.2. Yeah. So 8th question is completed. Then 9th. Okay, so 9th is easy. 9th and 10th. Okay. Okay. So who had doubt in 9th question? Who has question 9 as doubt?
I had
Okay.
a doubt.
Okay. So it states that A is a 3 cross 3 scalar matrix and the 1/1th entry of the matrix A is 4. So basically it is this matrix. So see, A is a scalar matrix and the first 1/1th entry of the matrix A is 4. That means the first entry of the leading diagonal is 4. This means that this is the A matrix. Yes or no?
Yes, sir.
And B is a square matrix of order 3 cross 3 such that ijth entry is equal to I square plus j square. So see, basically I represents the row number and j represents the column number. So it has given you the entire B matrix. Okay. So you just have to calculate each term. So see, it is a 3 cross 3 matrix. So there will be 9 terms. So this is first row, first column. So this would be 2. Okay. This would be 2. Okay, so you need not calculate the whole B matrix because if you read the question further, you will see that find the 2/2th entry of matrix 2A plus B, right? So you need to find this specific element. Yes or no?
Yes.
So what will be this? It will be I square plus j square. I is equals to 2, j is equals to 2.
16.
So this element would be 8. Yes or no?
Yes.
So this would be 8. Okay. So you need not calculate rest of the elements. Sorry. Okay. And now it asks you to calculate to find the 2/2th entry of matrix 2A plus B. Okay. So see 2A plus B, you need to multiply this matrix with 2. So this would become 8 0 0 0 8 0 0 0 8 plus B. So you know the corresponding element which we need to find. So you will add these two matrices and you can see that on adding this element and this element, you will get 16. Are you getting this?
Yes, sir. I got that.
Okay, so now 10th question.
Sir, 1 minute. Sir, in that question, they have
Yeah.
said that 1, 1th entry of the matrix is 4, not I, I.
It's a scalar matrix, so the
Oh yeah,
diagonal.
sorry.
Okay, fine. No problem. Okay, so is this clear?
Yes, sir.
Yes, sir.
Okay. So 10th question. A is equals to -1 2 -4 7 a square minus alpha a plus I is equals to 0. Okay. For some alpha belongs to real number, find the value of alpha. So you just need to substitute the A square matrix in this equation and A matrix and just need to solve it. Okay. I will do it anyways. So Whose doubt is this? Whose doubt is this? See, someone said 10th question. Whose doubt is this? Uh, I just need to ask whether I need to solve it further, or will you be able to solve it? -1, 2, -4, 7, minus alpha A. So -1, 2, -4, 7 plus identity matrix is equals to 0 matrix. So, okay, so this would be, I think,
Yes, sir. We'll solve it further.
okay,
I think the person has left.
fine.
You
Okay, so
told about the
yeah.
7th question, no, sir? That C.
Okay, so 3 activities are still left. How many people are there?
So you
Okay,
seventh.
so how many of you want me to continue in tomorrow's session instead of today, because it is quite late, I think, and most people have already left.
Yeah, please do it tomorrow, sir. Okay, sir.
Okay,
Fine.
sir, do it tomorrow.
Yeah, fine. See, I have no problem in continuing right now, but I see that strength has considerably reduced and very less people are present. So I think we should continue it in tomorrow's session.
Okay, sir. Thank you.
So were all of you able to understand whatever I explained?
Yes, sir.
Yes, sir.
Yes, sir. Absolutely.
Okay. Okay, so you can leave then.
Thank you, sir.
Sir, provide the link of the video that you have taught.
Yes, sir.
Hello, sir.
Yes, yes.
The YouTube link, sir.
I will post it in the discourse, okay?
Okay, sir.
Thank you, sir.
So where can we get this annotation of OneNote?
Annotations by, what do you mean by annotations?
So yeah, solutions just you have solved there.
Okay,
OneNote.
these solutions.
Yes.
Okay, I will try to post this notebook in discourse as well.
Oh.
Any other doubt?
So,
No,
is there any
fine.
specific section in discourse for Maths 2?
Yeah, there is a whole course, right? Maths 2. Under the courses subsection, you will find Maths 2 listed as one of the course.
Okay, sir.
Okay. If you don't have any doubt, then you can leave. Otherwise, you can stay and ask the doubt.
Yeah, okay. Good night, sir.
Yeah.
Sir, I have a doubt. It is not related to this. It is related to determinant.
Okay, so yeah, so is it from further activities of week 1?
Simple determinant calculation. Uh, if I'm calculating using row transformations, so I'm
Yeah.
getting different answers.
So you are saying that when you are expanding along different rows, you are getting different answers.
Yes.
Okay, so see, that is not possible, because when you expand along any row or any column for a matrix, you will get the same determinant.
No,
But
using row transformation. Using row transformation.
using row transformations.
Yes. Like R1
Uh,
is R1 minus R2.
okay. So you must be doing some mistake. Oh, or you must be doing some mistake, or you must be applying some wrong property, because I will explain that in tomorrow's activity. But if you want me to explain it right now, you can stay.
Okay, I'll stay.
Rest of you, do you have any doubt?
Sir, I have a doubt.
Yeah.
Sir, if possible, can you explain the interpretation of solutions for linear equations? System of linear equations with three unknowns. Like these,
Uh,
for these planes, when do we understand there is no solution and
okay.
there are
Uh,
infinite solutions?
okay, fine. So
You know,
you want me to explain? Yeah.
for two unknowns, we already learned in our
Okay.
previous classes as well. But for these planes, I don't understand.
Okay, fine.
For 3D planes.
Yeah. Okay. So see, a linear equation involving all the variables in R3 would basically be a plane. Okay. And the cases are same. That is no solution, infinite number of solutions, and uh, unique solution. Okay. So that would be best explained with a GeoGebra or some other graphical tool. I would be able to explain that tomorrow, because I would have to draw all those specific cases. So if you are fine with tomorrow, then I can explain it tomorrow for R3.
R3?
Yeah, you are asking in R3, right? R3, that
R3,
is the 3 dimension. You are
R3.
asking for higher dimensions, right? You have
Yeah.
seen in R2, that is the XY plane. You want me to explain it in XYZ,
Yeah,
right?
exactly. Yeah.
Okay. That I would be able to explain with a diagram, so I can explain it to you tomorrow.
Okay. That takes 10 minutes. Okay, thanks.
Yeah. Uh, Rest of you, do you have any doubt apart from Nupu, Gupta? Uh, okay, I think they are not present. Okay, so yeah, Nupu, you were saying something.
Sir, shall I share my screen?
Yeah, fine.
Okay. Or I will tell you the matrix first. Let me see what answer you get, because three of us solved. We all three of us got three different answers. So
Okay,
I will tell you the matrix. 1 minute.
yeah. So I'll stop presenting then, okay?
So no, sir. Wait. I'll
Yeah,
give you.
I mean, I'm stopping the recording. I will then share my screen.
Okay.